This is a topic from the subject of engineering thermodynamics. Topic is very simple. You know this already. PdV work. I am talking about PdV work, where P is pressure and dV is differential volume. V denotes volume. So you know that in thermodynamics you have studied so many processes: isothermal process, isobaric process, isochoric process, then adiabatic process, then constant enthalpy process. So many processes are there. And for each process, work done, PdV work done are different. Means expressions for PdV work done are different. Normally, these work done are given in terms of pressures and volumes. So let us talk about first isothermal process. Isothermal process means what? Isothermal process means constant temperature process. A process during which, better to say a thermodynamic process, here in this context, during which temperature is held constant or temperature remains constant. So for each case, we will use equation of state for ideal gas, that is PV is equal to nRT or P is equal to rho RT. But in both these forms, R's are different. R, capital R. When you are writing PV is equal to nRT, N means number of moles, and here R is universal gas constant or ideal gas constant. Capital T denotes temperature, which is absolute temperature measured in Kelvin. And when we write P is equal to rho RT, in that case, that R is not universal gas constant, that R is now characteristic gas constant or specific gas constant. It depends upon the gas, characteristics of the gas. Okay. So in engineering, normally we don't use PV is equal to nRT. We rather use P is equal to rho RT. And rho is what? It is density of the gas, mass by volume, mass per unit volume, density. Okay. So keep in your mind that here R is characteristic gas constant. So we are now interested in the calculation of PdV work done for isothermal process. So first you write, for isothermal process, PV is equal to constant, you know that. For isothermal process, pressure multiplied by volume. Here V is total volume, okay? Total volume. So again you can write P into specific volume. That is also constant. Specific volume is what? Volume per unit mass. Okay. Say we are talking about P into total volume. So P into total volume, capital V, is equal to constant C. Now, work done is equal to what? It is integration of PdV. And since PV is equal to constant, means P and V are dependent on each other. So here P cannot be taken outside the integral sign. To perform the integration, you have to write P in terms of V. So since PV is equal to constant C, therefore P is equal to what? It is C by V. So in the next line you write integration of PdV is equal to integration of C by V into dV. And C is a constant, so this can be taken outside the integral sign. Therefore, in the next line, it is equal to C into integration of dV by V, and integration of which is what? Log of V. And this integration is performed from state 1 to state 2, means it is a case of definite integral, so there will be no constant of integration. So state 1 to state 2, okay. So integration is what? Log of V. log of v to the base e, exponential e. So log of v from state 1 to state 2, so log of v2 minus log of v1, that is log of v2 by v1. So result is c into log of v2 by v1, and c is what? C is either p1 v1 or p2 v2. So this way you can calculate PdVWork. You don't need to remember all these expressions for PdVWork. In your exam paper, in the rough page, you can easily calculate. Within seconds, you can derive these expressions. Next come isobaric process. Isobaric process means constant pressure process. Pressure remains constant. Now, pressure becomes independent of volume. Constant pressure process. So, integration of PdV, here in the next line you can easily write, it is equal to P into integration of dV, because P is a constant. So, P into integration of dV from state 1 to state 2, therefore result is P into V2 minus V1. P into V2 minus V1, this is the PdV work done. So, this was constant pressure process or isobaric process. Next comes isochoric process or constant volume process. Means here V will remain constant. V will not change. Whether pressure changes or not, V will not change. Or due to change in pressure, there will be no change in volume of the gas. So integration of PdV, here since P and V are independent of each other, right? P and V are independent of each other. Therefore, P can be taken outside the integral sign. So in the next line you write P into integration of dV from state 1 to state 2. Then in the next line P into V2 minus V1. And since it is a case of constant volume process, therefore V1 is equal to V2. Therefore V2 minus V1 becomes 0. So P into 0 is 0. So for isochoric process or for isothermal process, PdV work done is 0. Next comes adiabatic process. You know that for adiabatic process, P into V to the power gamma is equal to a constant. Here again, V can be the total volume of the gas or the specific volume. Both are true. Okay, say we are talking about V, which is capital V, which is total volume. So P into capital V to the power gamma is equal to constant C. Here gamma is what? Gamma is the ratio of the specific heats Cp by Cv. Cp, C suffix P. This means specific heat at constant pressure, and Cv is specific heat of the gas at constant volume. For gas, specific heats are different for different processes. So, Pv to the power gamma is equal to constant is equal to C, and integration is what? It is equal to integration of PdV. Now we want to write P in terms of V. So, from the relationship Pv to the power gamma is equal to constant C, we are getting P is equal to C by V to the power minus gamma. P is equal to C by V to the power minus gamma, which is equal to C into V to the power minus gamma. P is equal to C by V to the power gamma, which is equal to C into V to the power minus gamma. So integration of PdV is equal to C into V to the power minus gamma dV. Then C is a constant, so you can take this C outside the integral sign. So in the next line it becomes C into integration of V to the power minus gamma into dV. And integration will be what? Integration will be V to the power minus gamma plus 1 divided by minus gamma plus 1. From state 1 to state 2. So this becomes C by minus gamma plus 1 into V to the power V2 to the power minus gamma plus 1 minus V1 to the power minus gamma plus 1. So this becomes C into V2 to the power minus gamma plus 1 minus C into V1 to the power minus gamma plus 1, and whole this expression you divide it by minus gamma plus 1. Now in the first, where V2 is there, in that case instead of C you write it is equal to P2 into V2 to the power gamma, and in the second where V1 appears, V1 to the power minus gamma 1 minus gamma plus 1 appears, there you write instead of C P1 into V1 to the power minus gamma plus 1, P1 into V1 to the power gamma, and this way in the next line you will get your desired result. So for any given process, to calculate PdVWork for any given process, whether it is polytropic process, in case of polytropic process, calculation procedure is the same, only that gamma will be replaced by n, where n is polytropic index. It is no more ratio of specific heats, it is polytropic index. Okay. So this way, so main target is what? You have to find out the relationship between P and V to perform that integration. Either you can write V in terms of P, or you can write P in terms of V to perform the integration. Okay, that is the target. Whatever relationship be given to you, but your target will be to write P in terms of V to perform the integration, or V in terms of P to perform the integration, to calculate PdVWork. Okay. Still, if you have any question, you can write in the comment box. I will try my best to answer your queries. Okay, thank you.